how do you determine how far away a star is? It's very, very difficult. No human being has actually ever been to another star. We've shown light away from our planet and our sun for billions of years, so some of our starlight has gone to other stars. But how do you actually measure these distances when they are so huge and so incredibly vast? There are a couple different ways, and one of the ways is using the concept of parallax. Now, parallax is defined as the shift in the position of an object relative to its background when it is viewed from a slightly different angle. Those of you who have ever messed with a microscope in biology probably had to figure out your dominant eye and work with parallax. If you have ever taken maybe a motorcycle class or a shooting class, sometimes they ask you to determine what is your dominant eye. And your dominant eye, the same test that's used for that, is also useful for demonstrating parallax. So here's what I'd like to have you do. With your right eye open and your left eye closed, I want you to take your finger and I want you to line it up with something that is straight up and down. So the edge of a doorway, the edge of a closet, the side of a picture frame, something like that. Then what I'm going to ask you to do is close your right eye and open your left eye. But do not move your finger. Okay? Do not move your finger. So if you just do it one more time, line your finger up to something that is vertical, like the edge of a doorway, and then without moving your finger, close your right eye and open your left. And what you should see is you should see, as this picture illustrates, that the image seems to move from left to right when you switch from your right eye open to having your left eye open. That is an example of parallax. Because of the fact that the eyes on your face are not located at the same position, when you look at an object from one eye versus the other eye, you look at it from a slightly different angle. And that's what produces parallax. Now, using this concept of parallax, astronomers can do something called triangulation. And triangulation only works for stars that are relatively close. Not every star is close enough for us to observe any parallax. The furthest distance from one point to another that human beings typically travel is from one side of the sun to the other side of the sun. So what astronomers do is this. They observe, let's say in January, they observe a star and what stars are behind it. And then we go through our little happy year. The Earth rotates around the sun, and 6 months later, in perhaps July, the Earth is now in its new position. It looks at the same star up here, and when it looks at it, it sees that this star has moved position from one place to the other, much like your finger moved relative to that tree in the last representation. By doing some math and some geometry, figuring out this angle and knowing this distance here, astronomers and mathematicians can determine with their data, they can determine this angle, and if they can determine that, they can then figure out this distance, and they can figure out with that distance and that distance, they can figure out the whole distance star to the Earth. Now, this technique is so commonly used that they invented a unit for it, and the unit is called a parsec. Parsec stands for Parallax Arc Seconds. If you recall, in one circle, there are 360 degrees. Those 360 degrees, each 1 degree can be divided up into 60 minutes of arc. And then 1 minute of arc can be broken up into 60 seconds of arc. And actually, this is a little bit confusing, so please cross that out in your notes. How this works is this. A parsec is defined as the change of distance that occurs when something moves 1 astronomical unit and the angle at which it's seen changes by 1 arc second. So 1 astronomical unit means how far the Earth has moved in 1/4 of a year. 1/4 of a year is 3 months. And they look at how far the distant star has moved, this is our distant star, relative to the background of stars back here. If the star has moved 1 second of arc in that 3 months where we have moved 1 astronomical unit, then that star is 1 parsec away. And that's 1 parallax arc second away. Now, a parsec is a distance unit. This measures how far things are. 1 parsec is about 3.26 light years. Light year is also a distance unit. One of the things that gets very confusing is if you are a Star Wars fan like I'm a Star Wars fan, Han Solo is standing there saying, I made the Kessel Run in less than 12 parsecs. It's sort of like I drove from Eau Claire to Minneapolis, St. Paul in less than 12 pounds. It doesn't make any sense because it's using the wrong units to measure what we're talking about. So, as it says, a long time ago in a galaxy far, far away, mistakes were made, but we still like Star Wars. Using this parallax method or this triangulation method, there's only a very few stars that are close enough for us to actually measure how far they are from the Earth. This process has been improved. In the 1980s. We launched the Hipparchus Satellite. The Hipparchus Satellite is useful for measuring this triangulated distance, and it is much better at it because it's up above the Earth's atmosphere. It does a much better job of gathering weak impulses of light. In 2013, the Gaia Satellite was launched, much more sensitive, and the purpose of the Gaia Satellite was to do triangulation, measure distances to different stars, and using the instrumentation on Gaia, we have been able to determine the distances to literally millions of stars. So increased technology has definitely increased this process. All right, that will do for this section. We're going to come back and talk about how bright stars are.